Okay, good morning class. So today we look, it's actually afternoon, but today we're looking at trigonometric graphs. So at this point we're looking at examples for exercise 6.9 and exercise 6.10. So on page 215. However, these examples is also on page 215. So, just refreshing your memory with regards to a tan graph, and the full lesson can be found in the description box below. We're looking at the tan graph. If they let tan of x equal 1, so what they did was, they drew the tan graph and the y is equal to 1 line. Okay? So as you can see here, what's happening? That this solution gets repeated every 180 degrees. Hence the reason why we say k times 180 when we're busy with that. Whereas in the sine and cos graph, that solution repeats itself every 360 degrees. That's the reason why we say k times 360. Okay. Let's carry on here. So we're looking at the first example, which is on page 215. Example 1 on page 215. Okay, so the question says solve for x. So number 1 is 3 tan x minus 20 degrees equal to negative 4,456, where x is an element of negative 90 to 270 degrees. Alright, so what's the first thing we need to do? We need to get the trig ratio on its own. Not so. Remember, I do not take the 20 over the equal sign. So I divide by 3 both sides. So tan of x minus 20, I keep the angle as it is, equals, then we say there's going to be negative 4.456 divided by, which is negative 1,485. Okay, so it's negative 1,485. So when I work out my reference angle, what do I do with the negative? I drop the negative. So the reference angle is then going to be arctan of that angle. Arctan of the positive part of that angle, which gives you 56,05. Okay. So which question comes to mind at this point? In which quadrant is tan? Negative. We just checked before we take the before we took arctan of that. So in which quadrant is tan negative? It's all stations to clear one. Tan is negative in 2 and 4. Okay, can you see that before? 2 and 4. So in quadrant 2, we now say, again, we don't take a 20 over the equal sign. We're going to lose solutions. We're going to lose values for true values for x. So we say x minus 20 is equal to, for quadrant 2, how do we get into quadrant 2? 180. Although we can get 90 plus, but I wouldn't use 90 plus here because the signs will change the cos will change the sign. So we just say 180 plus or minus, or 360 minus. So this would be 180 minus 56,05 plus k times 180 degrees. So x is equal to, put this in the calculator, 180 minus that answer plus 20. Give you an answer of 143,95 plus k times 1. Alright. So let's go on to quadrant 3 now. Quadrant 3. How do I get into quadrant 3? 360 minus. So that would be x minus 20 is equal to 360 minus 56,05 plus k times 360, not 360. K times 180. Why? Because the period on the tan graph is 180. So we solve for x here. So x is equal to 360 minus 56,05 plus 20 gives us 323,95 plus k times 180. Okay. So any confusion at this point? Okay. So what do you notice here? Is the restricted domain there. Okay, this is if this is general solution, this is where I stop. Okay. So the solution must lie within negative 90 to 270. So what do I say? X is an element of. And we start listing. We start with k is equal to 0. So let's check. So we're saying 143.95 plus 0 times 180, of course, going to give you 143,95. Okay, 143.95. Okay, then I try for 1, not so. I try 1, then gives me 323,95. Is it inside or outside?
Outside.
Do I have to write that?
No.
No. Now I go with negative 1. Gives us negative 36,05, which is 0. Okay. What will happen if I put negative 2 in here? Will also be outside. As you can see, it's negative 216,05. You guys understand? So this branch is now exhausted. Not so? So what do I do now? I try the other branch. If I put 0 in here, what am I going to get? 323,95. But that was the same answer when k was 1. Not so? So would I go with 1 now? Because that will be even further out than 270. So what do I do now? I try negative 1. So 323,95 plus negative 1 times 180. You get 143,95. Can you see that, people? So do I write it again? No. So now I try minus 2. So what do you think minus 2's answer will be? Negative 36,05. Wow, yeah. So what do you notice about tan? That the branches on tan is going to be the same. Why? Because moving from quadrant 2 to quadrant 4 is how many degrees? 180 degrees. Can you see that? From quadrant 1 to quadrant 3, it's also 180 degrees. Can you see that, people? And the angle, of course, is the same. Your reference angle is the same. So, because the k is k times 180, the cycle repeats itself every 180 degrees. It will repeat its solution also 180 degrees. So, when we're busy with tan, we just write one branch. Okay, because if it had lied in quadrant 1 and 3, you'd have seen the same thing happen as it's happening with 2 and 4. You guys understand? So for 10, you just write one branch. Now if you had gone and you have written this here, no problem, you're not going to lose any marks. Okay, it's just a repeated solution. You guys understand? Alright, so that is the first example. Let's look at example 2 for exercise 10.6. 6.10, sorry. Now we're looking at example 2. Here we have tan of 2 of x is, plus 3 is equal to 5, comma 1, 2. So where do we start? We first get the trig ratio on its own. How do I get the standing on its own? By taking 3 over. So it's going to be tan of 2x is equal to 5, comma 1, 2 minus 3, 2, comma 1, 2. Now what do I do? Arctan. So I say difference, 2x is equal to arctan of 2, comma 1, 2. So arctan of 2.12 gives us 64.75. 64.7. Okay. Do I divide by 2 at the stage? No. We take it first to the quadrant before we touch this reference angle. This angle. Okay? So what question comes to mind? Which quadrant? Is tan positive. As you can see, just before we took arctan, it was positive. Okay? So all stations to Claremont is positive in quadrant 1. Eh? Yes, Michael?
So when you are looking at like what quadrants?
Which quadrant is?
Yeah. Do you look at the solution they give you to solve as to?
No. We look here just before we have taken arctan. Just before this, we look at that sign there, and you can see it's positive. Okay, we don't look at the original sum given. Okay. Any other questions?
So it's like if it was.
Yeah, like say for argument's sake, this was negative, negative, negative. No? And we took that now over the equal sign. It becomes tan of 2x. Negative of that is equal to negative 2.12. Now I divide by negative 1. Remember tan of x was tan on its own. So tan of 2x is now equal to 2, comma 1, 2. When I work on my reference angle, I get 64.75. So I ask myself, in which quadrant is tan? Positive. Although the original sum was negative. I take a look just before I took that reference angle. Okay. Any other questions? All right. So the question is, in which quadrant is tan? Positive, and tan is positive in quadrant 1 and 3. Right. Remember for the tan, how many solutions, how many branches we write? 1. So you either write from quadrant 1 or quadrant 2. It doesn't matter. If you that kind of girl that want to go to 3 and 4, 3 or 4, you'll still get the mark. If you had written this branch and not the other. Okay? You'll still get the mark. So let's go with quadrant 1. How do you get in quadrant 1? 2x is equal to 64.75 plus k times 180. Where k is an element of integers. So what do I do now? I divide by 2. So 64.75 divided by 2. Give me an answer of 32.37. 32.37. Plus k times 9. Did I give you a restricted domain here? No. So that's your answer. So 32.73 degrees plus k times 9. Okay. For those of you who completed exercise 6.10. Yes. If you had said 90 minus, what's going to be the problem there, people? Tan must change to 1 over 10. So it's not going to be, it's going to be something different. So if I'm you and you work in general solution, always work with 180 minus and 180 plus your reference angle. Or 360 minus your reference angle. That's going to be safer for you. And if it's in that quadrant, it's just the reference angle. Understand? Don't keep yourself brave and use 90 and 270. Because the whole, everything in trig you know will go the other way around. Okay? Was there any problems with exercise 6.10? Number 3. For those of you who completed 6.10, they had a problem number 3. So we've got 2 tan x over 2 is equal to negative 0.8345. Right, so where do we start? Divide by 2 first. Okay, so that's going to give me tan of x over 2 equals negative 4,172 or 3. Okay, what's this? Negative 4,172. We got negative 8.345 over 2 gives us negative 4,17. So what do I do now? I work out my reference angle. So the reference of half x is equal to arctan. What do I do with the negative? I drop the negative. So arctan of negative 4.17, which is going to be positive 4,17, is 76,52. 76,52 degrees. So do I multiply both sides by 2? No. What do? I ask myself in which quadrant is tan positive? In which quadrant is tan positive? Quadrant 1 and 3. It's negative here. Now who's like 1 and 3? Where's tan negative? 2 and 4. But for the tan graph, we only write 1 graph. So let's go with quadrant 2. What will it be in quadrant 2? X over 2 is going to be 180 minus 76,52 plus k times 180. So x over 2 is equal to 180 minus 76,52 gives me 103,48. 103,48 plus k times 180. For those of you wondering why I don't add that, it's unlike terms, no? How do I get x on its own? You times by 2 throughout. That will give us x is equal to 103.48 times 2, 206,96, 206,96 plus k times. This must also be multiplied by 2, which is 360 degrees. What must I not forget? Otherwise I'll be losing a mark. K is an element of integers. This is one thing that will penalize you heavily on. Okay? If you leave that out, you're going to lose the mark. And if you don't lose a mark, remind me, so I didn't write this. Please take the mark off me, okay? Because in the final grade 12 exam, when we mark, we penalize them. Okay. People, anything else? So that brings us to the end of exercise and examples for exercise 6.8. For homework, please do the even numbers.